So hi, Alexander. Tell us, why do so many projects end up as a big ball of mud?
Oh, I have a little story to tell you about this. I had a little presentation yesterday about metrics for software architects. And we talked a lot about architectural metrics that measure architectural quality, structural health of a software system. And I asked the audience of about 120 people, how many of you guys would actually understand and know the architecture of the system you're working on to a degree that you can tell me what you could do, which would conform to the architecture, and what we couldn't do that doesn't conform with the architecture. Of those 120 people, exactly 3 people raised their hand. So I can only cite Forrest Gump here. If you don't know where you're going, it's unlikely you're going to get there. So it's unfortunate. It's a fact that about 90% of all projects end up as a big ball of mud, because people do not manage dependencies properly. They don't. If they have an architecture described in some PowerPoint or on a wiki page, and people have different interpretations of the architecture, or they're just not seeing as well they're coding. A developer works on the code and has tunnel vision for the specific problem he wants to solve, and he can't see all the side effects of dependencies he's introducing. And this causes at the end that you have more and more dependencies and everything is talking to everything, and then the structure is lost and it becomes much harder to work on the system.
And why does that architecture matter?
Well, let's look at the consequences of the big ball of mud. And that's also, I think, in the meantime, there's even some good research about this. How much time do developers spend reading code versus writing code? And if you have a big ball of mud, chances are that the developers spend 85 to 90% of the time reading code, trying to understand what it's doing and how it's working together before they can do any meaningful changes. Now, let's assume you have an architecture that keeps your code base clean and organized and modularized in a good way. Then chances are that the developers will only spend 70% of their time reading code and 30% of coding. So that's a 100-200% increase in productivity right away without doing much.
And what is good architecture? What does that look like?
Good architecture is an architecture that gives you options. Because if you work on software systems, you always shoot on movable targets, because requirements change, the environment changes, technology changes, and you want to be flexible. You want to be able to replace certain parts of your software systems if technology changes, if requirements change. And this is difficult to do in a big ball of mud. You want this modularity so that you can take a part, replace it with something else, or work on that part, add some new features that are useful, instead of just having to disentangle this thing all the time and then not having the options anymore. And on top of that, everything takes much longer. So you're becoming less and less agile, to say it this way, because you're fighting with technical debt, and making meaningful changes to a big ball of mud is hard. So a good architecture modularizes things, keeps independent components in your software systems. Almost like if you build a monolith and imagine you have microservices within the monolith that are cleanly separated and where you have minimized interfaces between them. That would be a good ideal architecture.
And how can you enforce an architectural model?
Yeah, that's an interesting question, because that's a relatively new topic, because there's been work on this topic for quite a while. There have been some open source projects. A very old one started in 2000, was called Dependometer, which basically allows you to define a very simple model in XML and then enforce, that only worked on Java, but you could enforce certain architectural rules and restrictions doing this in your build. Now we have new systems like ArcUnit, which are kind of cool because you can make a unit test and make it fail if the architecture is broken. The problem with ArcUnit is that it's a little bit hard to define a real architectural model. It's really, you have to maintain a lot of rules over time, and it can get a little bit out of hand if your system is bigger. Or use something like our product Sonograph. We worked on a new domain-specific language to describe architecture, and that has been on the market since 2011. Quite successful, and you use that domain-specific language to describe the structure of your software system. So to give you an idea, if you have something like 2-3 million lines of code, you would need something like 500, 600, 700 lines of DSL to describe the architecture for this whole system. You can maintain that description, that formal architecture description, with very little effort, and it's machine readable, so Sonograph can actually use that architectural description to find all the places in the code where the code deviates from the architecture. So you not only have a formal description and documentation of your architecture that is readable by every human, the language is very easy to learn, it can also be enforced, and you can prove actually that your software system is following the rules. And it's like source code. It needs to be committed to your version control system, and the architecture grows with the system.
And what benefits do you see from keeping a system in good architectural shape?
Since we're doing this since more than 14 years now, when I observe teams who follow the rules, in this case, I can see, first of all, they're way more productive because it's easier to find your way in the code. Everybody, if you do something new, I can only talk from my own experience with Sonograph. We're using Sonograph to develop Sonograph. I'm coding almost every day on the system, and in the meantime, I know exactly where everything belongs. We have a clear package naming strategy, and we know how the architecture looks like. We know which places you need to touch to do something. You get used to it. Still, occasionally I make a mistake, and then the tool tells me, and I can fix it. So it's easier to find your way around, so you become more productive, and it's a lot easier for new people to understand the code base, which is also important, because many projects, if they get a new guy, then he needs something like 6 months to become productive, because they don't know what they're doing, they don't understand the code base, and it's very complicated. So if you have a clear separation, a clear organization of your code, it becomes so much easier. So it's productivity, it's fun at work, and it gives you flexibility.
Perfect. Thanks so much for sharing your insights with us today.
You're most welcome. It was fun.